Unit 11, we're going to be proving theorems about lines and angles, specifically a lot of parallel lines. We talked about parallel lines before state testing because there were some questions about it, but we're actually going to prove why those statements that we made before were true. So we do have quite a bit of vocabulary for this first one. You don't need a protractor. Actually, you should be doing all of this without protractors because you're going to be proving it using logical reasoning. But we do have some vocabulary. So the first one is skew lines. Skew lines are non-coplanar lines. Okay, coplanar means on the same plane. Non-coplanar means not on the same plane. So skew lines are non-coplanar lines that are not parallel and do not intersect. Okay, so they're not parallel and they also do not intersect. And the reason why they can do that is because they are non-coplanar. So it's kind of hard to do an example of that. So I'm gonna do my best. So let's say we have a line going this way across the ceiling, and then across the floor we have a line going this way. Okay, so it's in 3D. So on the 2D picture, it's kind of hard to tell. But if you look at like our ceiling and our floor, those are two separate planes, right? If we have a line going this way across the ceiling, but a line going this way across the floor, they're not parallel because one is going horizontal and one is going diagonal, but they don't intersect because they're not in the same plane. Make sense? Okay. So those are kind of the more difficult ones, and really it can only happen if the two planes are parallel, right? So which is why they don't ever intersect. Okay, so then we're going to get to some definitions about angles that you are definitely going to want to have memorized. First, we have alternate interior angles. So alternate interior angles are angles, and I'm going to abbreviate. So angles that are non-adjacent, meaning they aren't touching. Interior angles, so they are angles that are non-adjacent interior angles, or and interior. Non-adjacent and interior. That lie on opposite sides. Of a transversal. Did I put transversal in there? No. Okay. So let me show you what I mean. If we have two parallel lines, we note that these are parallel by putting the little arrows, right? So we have two parallel lines. A transversal is the line that cuts through them, right? So a transversal would be that. Okay, so here's your parallel lines. This is called your transversal line. Angles that are alternate interior mean they're non-adjacent, so they're not touching. That lie on opposite sides of a transversal. So, for example, this angle and this angle are alternate interior. So they can't be adjacent, which means we can't use this one because it's touching this one. So they have to be not touching and on opposite sides of the transversal. Interior means inside the two parallel lines. So you can't use one on the outside. Those are called something different. Those are different.
It's kind of like interior vertical.
Sort of, but they have to, but vertical means,
They can be on the same side.
yes. So they're on, so they are, so the non-adjacent is a big deal because we can't say that these are alternate interior because they're adjacent, because they're touching. So they have to be non-adjacent, opposite sides of the transversal, so one on this side, one on this side, and on the interior of the parallel line, so inside the parallel lines. Did that answer your question? Yeah. Okay. So then we also have same side interior. Okay, so the nice thing is once you get to know what the different parts of the vocabulary means, it's pretty self-explanatory. So same side interior are interior angles. That lie on the same side of the transversal. Okay, so I'm going to redraw that figure. So here's my two parallel lines. I know they're parallel because I put the markings. Okay, here's my transversal. Okay, you guys ready? Same side, so that means they're on the same side of the transversal, and they are interior, so they have to be inside the parallel lines. So the two angles that are interior and on the same side would be this one and that one. Put two separate things. Does that make sense? Okay, so same side, interior, so on the inside. Huh? They don't have the same measure, and we'll get to that in just a second. Right now we're just identifying. So this is not in your packet, but let's just talk about it really quick. If that is same side interior, do you think we also have same side exterior? Okay, so exterior means on the outside. So if I have, I'm going to use a different color. If I have, let's say here's one exterior angle. What would be then the same side exterior to that one? The one on the bottom, okay? Don't put those markings, I just want to talk about them. Also, we could have alternate exterior angles. So if I'm talking about this guy, what would be the alternate exterior angle? Bottom right, this guy right here. Make sense? Okay. We will have theorems about those angles as well. That's just not what we're doing today. Today we're going to do same side interior. Okay. Okay. Two more. Corresponding angles. So corresponding angles are angles that are on the same side of the transversal. And in corresponding positions. So that means in the same position. Okay. Oh, I'm sorry. Hold on. Let me cut that. And let's scroll up. Give me one sec, guys. I'll scroll up for you. Okay. So my picture's going to be a little off. I wrote too big. Okay. Okay. So they are on the same side of the transversal in corresponding positions. So that means one will be an exterior, possibly, and one will be an interior, possibly. So for example, if I am looking at this angle, the angle that is in the same position on the same side of the transversal would be that one. Okay, so they're in corresponding positions. If I'm talking about this one up here, the corresponding angle would be that one. If I'm talking about this angle, the corresponding would be the bottom one. Okay? Make sense? Okay. So the first part of the lesson, we do have alternate exterior on here. So we'll talk about alternate exterior, but the first part of the lesson, we're just going to be identifying the different types of angles so you get used to the vocabulary. So the last one is alternate exterior. They are non-adjacent exterior angles. That lie on opposite sides of the transversal. Okay, so we kind of talked about this already. So in the picture, here's my parallel lines. I know they're parallel because I put the mark. So same alternate exterior. So that means they both have to be exterior angles. So if I am talking about this one, the angle that is on the opposite side, that's also an exterior and non-adjacent would be the bottom right one. Okay. And we're going to prove a theorem about that. Okay, so far so good? I know it's a lot of brand new vocabulary. Just, if you ever get stuck, just read and kind of think about what the word means. Alternate, meaning opposite sides. Exterior, they both have to be exterior. Okay? Same side, interior, same side, on the same side of the transversal. Interior, both have to be inside. Okay? So let's turn to lesson 1. Okay, so some of these, they go with our examples, but the definition is in there, so I did fill in the blanks for the definition part. So some of them, you're just going to have the definition in 2 places, which isn't a big deal. So we want to talk about parallel and skew lines a little bit. So parallel lines are coplanar, meaning they are on the same plane. They are coplanar lines that do not intersect. I don't know how much we've been doing this, but the symbol, if you do 2 long, straight, vertical lines, that means is parallel to. Okay? So let's look at a couple lines in this picture that are parallel. So if I have line AE, so let's write out line AE. We would say it is parallel to, so AE is right here, this one. What line is coplanar and does not intersect AE? DH. DH could be coplanar if we're talking about this plane. Or BF if we're talking about that plane. Either one. I'm going to say BF. Oops. So let's say BF is parallel to AE. So we would say parallel to line BF. Oops. Okay. Make sure that your notation is correct. So if it's a line, it has to have the arrows on the end. So I'm going to give you guys line AD. So really quick for me, figure out which line is parallel to AD. So AD is this guy. There's two answers here. If we are talking about this plane, the side of the box, it would be line EH. If we are talking about the top of the box, it would be BC. In my answer key, I had BC, so that's what I'm going to put. If you put EH, it's the same thing. It really depends on what plane you are talking about. Okay, let me erase that for the next one. So let's actually talk about skew lines. So skew lines are non-coplanar. So they do not lie on the same plane. We already kind of talked about this. They are not parallel. And they do not intersect. So if I am talking about AB, so let's do AB. So we're talking about this guy. I need a line that does not intersect it, is not parallel to it, but is not in the same plane. Christian, do you have one for me? FG. Oops. Okay, guys, let's think about this. FG, is it in the same plane as AB? No. Is it parallel? No. This one is going horizontal, and this one's kind of going diagonal. Will they intersect? No, because the planes, those two lines won't intersect because they're not touching. So, are those skew? Yes. Let's say, and line, which one was it? GF, are skew.
So the planes can intersect just
The planes can intersect as long as the lines won't. So another one that would be skew would be CG. So see how this one's going to extend forever going this way, and this one's going to extend forever going up and down, so they'll never actually intersect. EH would be another one. DH would be another one. DC cannot be, because one, it's parallel, but two, it's in the same plane. HG also cannot be, because they're not coplanar, but what are they? They are parallel. Okay? Does that make sense? It's a little tricky. We're not going to do, like I said, we're not going to do a ton with skew lines, mostly just identifying them. But there's no theorem we can prove about it. We also want to talk about parallel planes, though. So parallel planes are planes, that do not intersect. So for example, plane, I'm going to say ABCD is parallel to plane. So if we're talking about plane ABCD, that would be this plane right here. So which plane is parallel to that one? HEFG, or EFGH. So it's parallel to plane EFGH. Okay? Make sense? 3D objects are a little tricky. So you have to kind of just be able to really visualize it. Jen?
Is there any, symbol for a plane?
No, there is no symbol for a plane. You just use 4 points to name it. And you have to write out plane. I know, I'm sorry.
It was it's a lower ground.
I know, I'm sorry. Well, Sometimes that's used, but we're just to be on the safe side, we're just going to name it planes. Okay, guys, so here's what I want you to do. Numbers 1 through 4, you're just identifying different lines or segments or planes using the image to the right. So I want you to work together. I'm going to give you a couple minutes. See if you can answer those questions. Okay, it says which segments are parallel to segment AB? So we're talking about segment AB. Who can name me a segment that's parallel to AB? Jen. Segment EF. So you could have labeled segment EF. Okay, segments, remember, have just the line above it, no arrows. Did anybody name another one? David. DC, segment DC. Those are the only two because they have to be coplanar. So DC. Make sure you put the segment signal above it. Number 2 wanted to know which segments are skew to CD. So we need a segment that is skew to CD. Who has one for me? Jen. FG. So she is saying FG is skew. I would agree. So that would be FG. What else? Kevin.
Segment EH.
Segment EH. So that would be this one. Yep, that's not in the same plane. Were there any other ones, or was that it? Oh, wait, I see one more. 2 more. David? DF. EF. They're parallel. Mackenzie? AE. Yep, so segment AE. And then there would be one more. Christian? BF. Good. Okay. Make sense? Okay, now I'm just marking everything on there. Jen, yeah? Which one are you thinking? EH? BH? Because it's not marked, I wouldn't do it. Because it's not marked as a segment on there, so I would say no. If it was marked, then sure. What are 2 pairs of parallel planes? Who can name me 2 parallel planes? Lily.
Plane A, B, and EF.
A, B, C, D is parallel to plane, which one? E, F, G, H. Good. Did anybody do a different one? Kevin?
Plane ABEF.
A, B, E, F.
And plane DCGH.
D, C, G, H. Yep, there's only 2 sets. What are 2 segments that are parallel to plane B, C, G, F? So B, C, G, F is the back of the box. I want 2 segments that are parallel to that. Jen? Where's the other one? Oh, the front and the back of the box. Yeah. So you could have done A, D, E, H, and B, C, G, F. Yes, those are also parallel. Good. Sorry. So if I'm looking at the plane that's the back of the box, what are 2 segments that are parallel to that? Christian? AD and EH. Good. AD, EH. I think those are the only 2. Okay? We can't go the other way. I mean, I guess we could. AE and DH. It needs to be parallel to the back.
Yeah, so there's the
A, D, E, H.
EH, and then there's also AE and DH.
The only thing I would say about that is the plane. I don't know. I think, yes, you could say those 2. Okay, questions? So far, so good? Okay. Okay, so we're going to talk about transversals. So here's a diagram for you. A transversal, so let's label that. This is why I didn't put it in the vocabulary, because it's in here. is a line that intersects two or more, they don't have to be parallel, two or more coplanar. So the lines technically do not have to be parallel, but it's when the lines are parallel that we can make some assumptions, okay? Interior means inside the two coplanar lines, so anything in between the two coplanar lines. Exterior is outside of those coplanar lines. And then we have a bunch of angle pairs. So we already did these in the definitions, but we're going to do them again, and I'm going to have you guys identify them. So alternate interior angles are non-adjacent interior angles that lie on opposite sides of the transversal. I'm only going to have you put one pair. So if I say angle 4, what is an alternate interior angle to angle 4? Angle 6. Can you find the other pair of alternate interior? 5 and 3. So angle 5 and angle 3. Okay. So alternate interior. Same side interior are interior angles that lie on the same side of the transversal. So there are two pairs of same side interior angles. Find those for me, please. Okay, what'd you guys get? Who can help me out? 4 and 5. Angle 3 and angle 6. Good. Okay, those are your same side interior. Corresponding are angles that lie on the same side of the transversal and in corresponding positions. Okay, for time, I'm just going to tell you. There's a whole bunch. So I'm going to just tell you a couple. So angle 1 and angle what? 5. What about angle 3 and what? 7. 3 and 7. 1 and 5. 2 and 6. 4 and 8. Good. Okay. Last one. Alternate exterior are non-adjacent exterior angles that lie on opposite sides of the transversal. So find me the alternate exterior. Okay, first one is angle 1 and angle what? 7. And then the second one would be angle 2 and 8. Good. Okay. That's lesson 1. Just identifying those. Not too bad? Okay. 11.2 is where we're going to start using those to prove different statements. So is everybody ready to move on?